Hello, welcome to my video tutorial. Tonight we will be tackling Hamiltonian paths and Hamiltonian circuits. And what is the difference between Hamiltonian paths and circuits and or between Euler paths and Euler circuit? Hamiltonian path is a path that visits every vertex once with no repeats. Hamiltonian circuit is a circuit that visits every vertex once with no repeats. So the difference between Euler path and circuit between Hamiltonian path and circuit is that Euler uses edge while Hamiltonian uses vertex. Or rather, Euler deals with edge while Hamiltonian deals with vertex. So note, the difference between a path and a circuit is that circuit returns to its normal position. And I will give examples of graphs regarding Hamiltonian path and Hamiltonian circuit, and we will define which of the graph is a path or a circuit. So let's try example number 1. Is this a Hamiltonian path or Hamiltonian circuit? But before solving, there's a note. So in Hamiltonian path or circuit, it does not have to cover up the edges, only the vertices only. Okay, so we don't have to cover up the edges if we need to prove that it is a Hamiltonian path or Hamiltonian circuit, unlike a Euler path or Euler circuit. So let's try to solve this example number 1. So again, is this a Hamiltonian path or Hamiltonian circuit? So let's try to solve this. If we're going to start here at point A, is our starting point. Starting vertex, okay, starting. Okay. So remember, in Hamiltonian path or Hamiltonian circuit, it's like you're just delivering from one point to another point. Okay? So how to solve this? We can go here. This is our first stop. Next, then from A to B, then from B to C. After going to C, there is DB is no 1, 2. C, we can go to F. We will go to F. So that is number 3. Next, from F we can go to E or D, but I will choose letter D. So I'll go to D. This is our number 4. And D, and from D to E. This is our number 5. So it shows that this graph is a Hamiltonian path. So this graph is a Hamiltonian path. So we saw that this edge and this edge are not used up. So as I've said a while ago, in here, Hamiltonian path or circuit, it does not have to cover up edges, only the vertices. We can see E is our ending position. So it's like you're traveling or you're delivering from point A to point E. So next example. Is this a Hamiltonian path or Hamiltonian circuit? So you can pause the video to solve if it is a Hamiltonian path or Hamiltonian circuit. Okay, let's try solving it again. As I've said a while ago, in Hamiltonian path or Hamiltonian circuit, it doesn't have to cover up the edges, only the vertices. So we can start at letter C. This can be our starting position. Okay, so from C we can go to B, or we can go to B or D, but I like to go to B. Okay, we can label this number 1. So from B I can either choose D, E, or A, but I will choose A. So this one, number 2. From A we can go to E. 3. Next, from E to D, number 4. Lastly, from D to C. This one is number 5. So as we can see, from 1, 2, 3, 4, 5, we ended where we started. So this is also our endpoint. So we can say that this graph is a Hamiltonian circuit. So we already identify if a graph is Hamiltonian or Hamiltonian circuit. So let's remember that Hamiltonian path or circuit and circuit deals with vertices, while Euler path and circuit deals with edges. So let's take note. In Hamiltonian path and circuit, we do not have to cover up all edges, only vertices. So in our next lesson, in our next video tutorial, I will be discussing Dirac's theorem and Orr's theorem. Hope you understand our lesson. Thank you.